Good afternoon, everyone, and welcome to today's webinar, 21st Century Blast Freezing, brought to us by FPSA member Tippmann Engineering. Our speakers today are Bob Tippmann, President of Tippmann Engineering, and Dan Tippmann, Chairman of Tippmann Engineering. My name is Anne-Marie Penaranda, and I am the Operations Manager here at FPSA. This webinar is being recorded for those of you that are FPSA members. Please let your colleagues know who are unable to listen to it live today. Know that they have access to it in the members only section of the FPSA website. And for those of you who are not FPSA members, please send me an email and I'd be happy to provide you a link to the recording. Before I pass this over to Dan, just a few housekeeping items for today's webinar. All attendees are muted by default, but you will have the opportunity to submit text questions to me today by typing in your questions into the questions pane of the control panel. You may send your questions at any time during the presentation and at the end of the presentation, and we will send them I will forward it to Dan and Bob. Thank you again, and let's get it started, and give me a second to pass it over to Dan. So let's begin his presentation. Dan?
Very good. Thank you, Anne-Marie, and thank you to the FPSA for the opportunity to do this presentation. So the title is 21st Century Blast Freezing, and we're really going to talk about kind of where we've been in draw-through in-rack freezing and the lessons we've learned, and we end up setting goals for our new product development. We'll introduce that and go through some details, and then at the end, if we have time, we could do a live demo, and then we should have a question and answer period. So here we go. So we talk about draw-through in-rack freezing. Our first installation was back in 2008. We've done progressive improvements and developments since then. So the first, and I think one of the most meaningful, was the swing seal in 2010. We'll kind of mention that. That provides automatic height compensation to accommodate up to a 20-inch variation in pallet height mix with no touch adjustment. We then went to direct drive axial fans in 2013. That provided significant improvement in CFM per horsepower, so there was an efficiency improvement, and it is much more straightforward. There were no bearings and belts associated with the direct drive fans. And then people keep wanting to go faster, so one of the challenges we ended up facing with freezing was spacer performance. The vast majority of users use what we term egg crate spacers, and those have a history of, I think, causing or aiding in the crushing of cardboard on cases, especially wet cases. So we ended up developing the T2 spacer to address cases that have integrity issues during freezing. So it provides improved airflow for those cases, and it provides improved support. So in 2016, we kind of passed a milestone of our systems are freezing over 10 million pounds a day. So I think there's pretty wide acceptance of this technology. And then in 2018, we began field testing of our new offering. We call it QFM, and then we show the release in 2019. So here's just a quick video graphic that kind of shows the existing QuickFreeze offering that we've offered for the past, what is it?
12 years.
12 years, yeah. So it kind of shows the array of pallet heights. You can mix pallet heights in the same system, and it shows the operation of the swing seal at the top. Notice when that pallet is engaged, it deflects that gate and blocks off any space above while providing open space for these spacers to breathe. So you can see we bring air in from the aisle. It's induced through the pallets because we have fans exhausting off the top of that plenum space. And then we can see through this wall. We just left it transparent for the video, but that would all be sealed off. So we're creating a reduced pressure plenum. And then when you push pallets up against the opening, the only pathway for the air is exclusively through the spacer area. And that's why we get the kind of performance we get with the QuickFreeze. So like I mentioned, QuickFreeze really is universally accepted in the industry as the fastest way to freeze palletized products. So at any given temperature, this is the fastest technology available for palletized product. We do utilize draw-through technology, which against the reduced pressure plenum, we're inducing or pulling air through the pallets. That enables us to achieve excellent velocity between the layers of products, and that gives us our excellent freeze performance. And those features combined enable significant cost reduction per pallet. And we go through, we have some ROI and some costing tools later in the presentation. But over the past 12 years, we've really learned a lot about how people utilize the systems, and we really wanted to offer a new offering that helped overcome some of those challenges, and we really feel like we've done a great job with our QFM offering. So Bob,
so some of the things that we really wanted to address in this was number one was lead time. The time it takes to build a blast cell or build out a QuickFreeze system could take many months up to a year to really, from the day you decide that you want to start freezing to having that system installed and running, can be a long lead time. There was also this with QF Plus and with QFR, there's a problem of vacant pallet position, where if you don't have all of the pallet positions in a zone in the system filled, then you'll see reduced performance on the remaining pallets that are in the system. And we knew that if we increase the CFM per pallet, that it would increase the performance, but it amplifies the vacant pallet position problem. So we wanted to figure out how to address that. Finally, when people went from blast cells to QF Plus, we saw a significant reduction in handling time, and really some of our users were able to get away from batch rotation of the products, but there was still some of that on even a zone by zone basis. There was still some batch handling of product. And then finally, being able to communicate to the customer and to the operators if they had engaged the system properly and they had a good seal on the pallet. Last things that, if we could get to them, we'd love to be able to add these to QFM would be, there really isn't a whole lot of individual pallet data when it comes to freezing. You might get some batch data or some truckload data or something like that, but really there is no individual data on a pallet of how long it was in what temperature room, anything like that. We'd also like to see WMS integration. We had some operators on QF Plus that did a great job integrating QuickFreeze with their WMS, but we wanted to make it easier for them to do that with this new product. Seasonal demand. We saw this quite a bit with hams and turkeys, where they would have a very high blast demand that would go away for the rest of the year. So we wanted to be able to help them address that. And then on the horizon, we see taller and taller buildings, and being able to build systems that would work well in 100-foot tall buildings. We wanted to have something that would work well in any situation.
So that led us to this modular design. So it gives us one fan and a plenum per pallet position. So that enables us to tailor the performance down to the pallet. So we have incredible CFM per layer. We get outstanding performance. So the technology itself is very proven with QF Plus, but it's really a significant bump in performance with additional airflow and all the controls that are associated with this. And then lastly, this system is mobile. If you look at the right-hand photo, the system is fastened to your 2-deep racking arrangement. And especially the larger users, they may have demand at one plant increasing while another plant has reserve capacity. If that happened to be QFM, you could put those units on a truck, transport them to the other facility, and be up and freezing in a handful of days. So here's a few photographs of some installs. The photograph on the left, this customer wanted to do exclusively floor freezing. They were very excited to be able to do all of their freezing handling utilizing walkie riders. They're also freezing product that had some significant purge, and this really expedited cleanup. There wasn't purge dripping down through the racking like you would have in either a conventional cell or even in QF Plus or QFR. And then on the right-hand side is an installation multiple levels high, and this is in a drive-in rack arrangement.
So going through our wish list of what we could design around, quick lead time, we have units on the shelf in stock ready to ship out. So you can literally go, it's less than a week lead time as long as you have the standard 2D select rack with structural beams, then you can install these in less than a week. And as long as you have the refrigeration or whatever ancillary system components are there, then we're there in less than a week. And then we were able to, you can get this in any color as long as it's black. It was really important to us that we had a universal design, that we weren't engineering this piece of equipment for a certain space, so that you were able to pull it, move it to a different location, have it serve all kinds of different products that you might want to blast freeze. We also have very standard pricing that enables you to plug these into your budgets or CapEx planning, so that you can, there's no mystery there. People are using these in new construction, retrofits, and then adding blast to existing facilities, which traditionally has been very cumbersome and costly and just hard to do. And the ROI has been very impressive in being able to reduce the CapEx spend at the beginning and the ongoing operational costs.
So it is very design friendly. Bob mentioned a universal design. We do that by the system telescopes up and down to accommodate the rack opening, and the system can freeze pallets from 40 inches to 94 inches, which that encompasses every pallet I can recall seeing in a fresh to freeze environment. So we do have, Bob mentioned the 2D structural beam rack arrangement, and then we also do have adapters available for drive-in racking.
So it's very simple to install and remove. We have on here that it takes as little as 10 minutes. I think that it's more like 6, 7, but we'll leave it at 10. And then we're finding now the installed electrical cost is actually less than our previous system, because there's no starters or VFDs required since it's EC motors. And then you run a panel out to the space, and you can feed. It's actually 20 units per circuit, and however many circuits you might have in your sub panel. So on there we said 7 with 140 pallet positions.
Here's an example plan view layout. So we have these AutoCAD blocks available. So if you want to lay these into your own facility, you can do some space planning, or we're more than happy to assist you in layouts and discuss your needs, but we're happy to share these kind of details. So here we're jumping into something that's near and dear to both Bob and my heart. We talk speed versus efficiency. And really because QFM delivers such high CFM per pallet, we achieve a very high velocity in the spacer area. It's approximately 3 meters per second. So that additional airflow really does help reduce freeze times, or you can do keep the dwell time the same and run with a warmer room. So that's really where some of the ROI dollars come from, is the refrigeration system supporting your freezing operation. If it can be operated at a higher temperature, your costs per ton are significantly reduced. And then Bob already mentioned the EC motor. That's electronically commutated, and again, it doesn't need a starter, and it has built-in speed control. And the next bullet we're really excited about is the system can freeze products so quickly that many times the facility can take advantage of off-peak freezing. So if you have a very attractive off-peak electrical rate, the system with its onboard controls, it can be set to run the fan speeds all the way. You could turn the fans off, or you could run the fan speeds way down to reduce the refrigeration need for a certain window of time to match your on and off peak schedule. And then we do have auto start and stop. So the fan only runs when it needs to run. So we talked about the occupancy problem earlier. And this system, if there's not a pallet in front of it, the fan will not run. So it does not have an occupancy problem. And we're not spending watt hours on a fan that's not doing work. So Bob's more up to speed on all of the controls offerings, and I'm sure that'll come up in subsequent posts here. We mentioned the operational friendliness, where we have the same swing seal arrangement we do on QF Plus. So we're able to accommodate a pretty wide mix of pallet heights with the same machine. And really the intent is to do any pallet anywhere, so the operators don't have to wonder what pallet can go into what location. And then
so on the auto start, we've actually got a LiDAR sensor in there that's constantly measuring out in front of it, and when it senses a pallet has been placed in front of it, it's going to start the cycle. And the first thing it does when it starts the cycle is it performs a seal test. The reason that we do the seal test first is we want to communicate with the operator that just placed that pallet and let them know if they've got a good seal or a bad seal for that pallet. So that seal test is completed very quickly, and it gives near immediate feedback to the operator with the LED that shines through the opening in the pallet. And it also sends communication back to a dashboard that we can provide, or to your WMS. When the timer on the pallet expires, the fan shuts off automatically, or if someone pulls the pallet, it shuts the fan off automatically, or you can send a pause or a shut off command from the dashboard.
And one of the other design goals was to have really a no maintenance machine. We didn't want people to have to do, motor or shaft lubrication. So there's these motors have permanently lubricated low temperature bearings. And then the rest of the unit is very robust. It has a stainless steel base, plenum, and the exoskeleton is stainless steel. And then the vertical seals and the telescoping members are hard coat anodized. So it's a very rugged, very durable assembly. And then safety-wise, we have both inlet and outlet fan guards. So obviously, there's no problem with the fan operating near people. We also use NEMA twist lock cords between the units. So we'll talk more later in the presentation about electrical, but the units are daisy chained together. And then we do utilize a noise reduction propeller. So there's not any challenges with sound power with these operating in the freezer.
So it was important to us that whatever products we release and sell are reliable, and we field test QFM for over 24 months with no equipment failures. It was also important to us that even though we have all of these state-of-the-art controls on it, if any of the controls were to fail, then the fan switches over to run full speed, because we don't want it to be for it to happen where they place a pallet, something goes wrong, and the fan doesn't turn on. There's an SD card on the control box, that backs up data locally, and it's got enough storage for 60, 70 years, so that's never going to run up, I'm hoping. Dan mentioned that it has low temp grease. Every component on there is rated to at least -20. I think most of the components are -40. It's an industrial design and extremely strong exoskeleton design. And then we warranty these units for 3 years. No, the warranty from the fan manufacturer is actually 1 year, but we umbrella coverage over that and warranty the entire thing for 3 years. Okay, now we get to talk a little bit more about, they call them the smart features or the controls on this. I'd already mentioned that it'll turn itself on and turn itself off whether there's a pallet in front of it or not. Each unit is a Wi-Fi device, so we're getting into, this is an IoT or Internet of Things device where you need to provide wireless access to get all of the features that are really available on these. Programmable dwell time. The units can be controlled in a number of different ways, but the most basic way is to set a general timer for each pallet. It might be that your range of SKUs, you might have a 24 to 36 hour freeze time, so you would set all of the units to run for 36 hours. And that's kind of the basic or the introductory integration. When you are able to complete we call it the SKU profiling and extrapolation process. So with that, it's we're getting into variable retention time here. So being able to collect data, every SKU freezes on its own schedule, and being able to capture that data, and with the help of our software, we can then help to make the decisions on when each pallet would be ready. In order to do that, we need that integration with your WMS. So it kind of starts out as, day one, you'll have fixed retention time of every pallet set to 24, 36, or 48 hours, depending on what kind of stuff you freeze. And then the more SKU profiling you do, the better the data collection, and then get that WMS integration happening, and now you have a variable retention time system. There's also, with these SKU profiling, there's a couple of new freeze strategies. One would be if the room temperature warms up and you're trying to freeze, then we're going to extend that dwell time to compensate for that. Or if the temperature in the room goes down, then we're going to shorten that cycle time on the fly. There's some other things out there that people have talked about, and these can now be implemented, such as pulsing or varying the fan speed throughout the cycle. We've seen that with tempering, where they want to run it at high speed until they hit a certain temperature, then they want to turn it down. So there's different strategies that you can work out with the QFM that really were not available ever before. So remote monitoring, we provide you with some dashboard software that you can monitor these units on the fly. You can see what the temperature is. We have some aggregation of data, so you can see trends and calculate utilization of your system, things like that. Over-the-air updates, so these units are only going to get better over time with us being able to release firmware updates that have new features. We've got a pretty exciting new firmware update coming down the pipe right now. Fan speed control, you can control that on the fly on an individual unit basis, or as a group, or as part of a profile. Dan talked about being able to schedule times that the units run or don't run, so that you can capture some of those utility dollar savings. And then from there on, it's data. Temps, times, how did that pallet do on the seal test? And when you have that integration with your WMS, then you can see how your operators are performing and be able to more accurately understand what the costs are associated with blast freezing.
Yeah, the other thing I like about the dashboard is many of us in operations have dealt with challenges managing the turning of fresh to freeze product. So many people use a chalkboard or whiteboard in the operations office, and the dashboard that Bob's talking about, one of the most attractive or popular screens is the operations screen, where it summarizes the status of all the machines. So it'll say there's this many machines in operation, there's this many that are available to load, and then it will show you a group of machines that are completed and ready to be moved. So it really gives you some nice tools to better manage the operation, and it really, a lot of synergies come to play when we're able to talk with the warehouse management system and really better utilize the capabilities of the system. So when we're able to turn the faster turning products faster and allow the dwell time on the slower turning products, we're able to significantly improve the overall throughput through the system. Here's a quick explanation of kind of the nuts and bolts of the machine. So from the left, it shows the unit telescoped up to its maximum beam to beam height. And then you see there's at the very top, it's showing a connection to a horizontal rack beam, and that details upper right. So it shows the clamp assembly grabbing that rack beam. And then if you look down at the bottom, there's that B detail that's down below, showing how the unit sits and is gripped with the bottom fixture. And the next graphic is the unit telescoped upward, and it shows the width of the unit. And then there's on the right kind of the isometric view showing kind of the major components, and then the side view. So there's a just pretty good explanation, and helps people do, first of all, understand what the unit looks like, how the telescoping works, and how it can fit into their operation.
So talking electrical, these units are 480 volt, 3-phase, 60 hertz. They consume 600 watts, and you daisy chain them together with the NEMA twist lock cords and caps. Those twist lock cords are very easy to lock out, tag out, as they have on the ground plug, they have a place where you can place a lock, and then you can put up to 20 of these units on a 25 amp circuit. Here's our electrical detail page that we can send you these as PDF after the webinar, but it kind of illustrates that daisy chaining of the units together. And then if you had a sub panel, you would have an outlet at each level that the first unit would plug into, and from there they daisy chain across up to 20 per row.
So again, the racking recommendations, we have two options. Number one, 2 deep select rack with structural beams like shown in the graphic on the right. And then again, we can interface with drive-in rails. So we do include some information, and these graphics are available to share for a specific project. So we can help you with clearances, and we have another page with racking details that show, suggested capacities and sizes, and it really just helps take the mystery out of where the units can go and fit and attach. So here's a quick 2-page racking requirement list. So we're more than happy to share all these details, but it's just, we like to see good quality structural steel racking systems utilized. Number one, obviously to carry the weight of your products, but secondly, the throughput and the number of turns you get through a freezing location dwarf your storage locations. So if you're going to spend money on durability and bullnose deflectors and double boxing, all the things that can increase the ruggedness of your racking system, your freezing area is the place to invest those dollars.
All right, so when we're talking about where you're installing QFM in new construction or new additions to your existing building, you would provide the racking. You can get the same racking as you would get throughout the rest of your warehouse. You provide power and Wi-Fi, and then depending on the size of your order, we have a few hundred here in stock, but if it's significantly more than that, then we need a little bit of lead time to be able to manufacture those and get them over to you. The best part is they install overnight without any interference to the construction or operations. It's we're not in your way. It's literally 5-minute installs on these units. And then anytime that you guys are planning a new freezer, you should include additional capacity for future freezing, so that out of everything that it takes to be able to have a successful blast operation, refrigeration equipment takes the most time and really costs significantly more if you buy that equipment further down the line. So if you size your vessels and some of your piping, just kind of do a little bit of master planning on the refrigeration system, and that'll pay dividends in the future.
Absolutely. We do see a lot of retrofit because of the ability to add freezing into a facility that has not previously offered freezing. We're a great fit for a retrofit. So if either you need to expand your current freezing capabilities, or you want to start offering freezing services at a location that hasn't previously, this is a great solution. And Bob did mention the infrastructure on the refrigeration. We've had multiple customers be able to eliminate their low temp suction. So they were able to basically increase the low temp house suction, which paid big dividends, number one, on capacity, because their existing equipment was able to perform at a much higher refrigeration capacity at a lower horsepower per ton. And it expanded their ability to take on additional freezing. And in these installations, the only thing they had to add was they had to supplement the condenser capacity. We kind of already mentioned, so when you're adding blast to an existing facility, again, that there's, I don't know, or nationally what the percentage of facilities that do offer blast freezing, but many of the 3PL freezer operations do not offer freezing. But the ones that do have additional refrigeration capacity, this is a great way to dip your toe into offering freezing services at very low CapEx costs. We do tell people we'd like to see a minimum of 5 degrees temperature difference between the target temp. So most product, you're looking for a 0 degree core temp. So if your freezer is -5 or below, we can turn most products in 48 hours or less with this system. And Bob already mentioned incredibly fast installation. These literally go in on a new construction. We can easily get in and install these during pull down. So we're not having to do a lot of gyrations with schedule around other people in their sanding rack or working on doors or any of the things you see near the end of a construction project. We can be in during pull down, getting these systems installed and ready to go by the time you're at temp.
This is at the beginning of the presentation, I mentioned that straightforward pricing is something that's important to us. And so here it is. There's no mystery in anything that we're doing. If you buy up to 104 units at one time, the price is $44.95 for each unit. And then if you go above that, so that's 2 truckloads is basically the break point there. And then when you buy 2 truckloads, it goes down to $3,495 per unit. The units ship out of Fort Wayne, Indiana, and then we commission them in Fort Wayne. We program them with your Wi-Fi instructions, and then when they get on site, then we assign them to the correct rack location and help you with commissioning and getting that process going of profiling all of your SKUs.
So here's some ROI tools we offer. And the first thing we always do is we look at kind of the size of the operation you're contemplating. So we need to get an idea. When we look at initial costs, we have to size the system. So we really need to know, what are we doing? Are we freezing, thawing, cooling? And then what are we working with? We need to know the product type, the throughput in pounds per day, all these details, so we can basically size the system. So there's a questionnaire that gets sent out. And when this gets returned, we can turn the crank and determine not only how many QFM systems we're projecting you're going to need, but we'll also share the heat load calculator that projects the recommended refrigeration support that area is going to need. Then there's the option to compare different solutions for your throughput. So this array, there's the details of the program are on the left. This happens to be export poultry, 2 million pounds a day, 1,700 pound pallets. So the three options that are being compared are blast cells, QF Plus, our original offering, and then our latest offering, QFM. So what we wanted to do is capture the equipment, so the freezing system costs, and we also wanted to capture the cost of the refrigeration system needed to support that technology. So if you look real quickly, the refrigeration costs for the blast cell were $13.3 million, while the installed cost of the refrigeration system for both QF Plus and QFM was under 10 million. So not only is your installed cost of your refrigeration system often significantly less costly, but our ongoing costs, our utility costs and handling costs are significantly reduced. So we provide the tools to be able to make as informed a decision as possible. The next thing I'd like to do is here's the kind of the analysis we use to generate the column on the left, the blast cell column, and a QuickFreeze column. So this program was a poultry freezing operation, and the user had a design where they needed 546 pallet positions in a conventional blast cell to get the work done. And they knew their costs, and we were asked to come in and propose what we could do with our QuickFreeze system. So we were able to put in the freezing system, the electrical, the refrigeration, and do a comparison. So in this example, QF Plus total in was 4.35 million, while the conventional blast cell was 6.1 million. So this tool is available, and it's just helpful when you're comparing different technologies. The next part is really how much am I spending to freeze each pallet. So there's utility costs associated with the fan, power, your evaporators, and the rest of your refrigeration system. And then secondly, there's handling cost. So notice all of our freezing systems are a single deep arrangement. So the handling, so the number of pallets per hour an operator can perform are significantly better for the single deep versus the conventional blast cell, where the operator is having to navigate several pallets deep in a drive-in arrangement. So we have an inherent advantage on the refrigeration because we're operating at a higher temperature for the same turn time, and we have a significant advantage on the handling. So it really does give the end user a significant advantage when they're competing for fresh to freeze work, and it helps them determine really what their cost per pallet or per hundredweight or whatever the metric happens to be. Here again is one of the install photos. This happens to be drive-in racking. And again, there's that floor system. Notice the green LED at the base there. That's one of the status LEDs, and that's basically telling us that all those green lights, those are available, ready to freeze product. You want to talk about?
Yeah, so we also have units that we can send you so that you can do some profiling before you invest in a larger system. And it gives you, it's the same as having, it's the same unit. It's not any, the unit's not any different than what you would get in the full system that you would get. So you get exactly the same performance as what you would see with a full system.
I think a lot of people find it helpful to see their product freeze in their facility. And if they have their own quality assurance group, they can deploy their own time, temperature, data acquisition equipment and get their own results.
Yeah, there's just no guessing at that point.
Yeah.
So yeah, we can talk you through, we talked about filling out that questionnaire, get a unit there, and then the reporting and test data used to be a cumbersome process, but now it's all built into the QFM, where there's a probe that we can provide you that plugs into the control box, and it logs the air data and the product temperature data and puts that on a graph together. So it's literally a couple of clicks and you have your report on the performance of the freezing. Kind of looking forward, we see the increase in ASRS, and here's kind of a mock-up of how QFM can be integrated into an ASRS. It can attach directly to the rails, and there's no restriction on number of pallets high, where on our older system with the shared plenum, we were kind of reaching maximum height at 40, 50 feet. And some of these buildings going 80 to 100 feet, you really need something like the QFM to be able to do that. And then this is kind of this is where we have fun. We like to talk about what's next. I had mentioned that over-the-air updates provide us with the ability to improve the QFM in the future at no additional cost, and we're getting ready to share our latest firmware here in the next couple of weeks. We'll publish the new features that are available on that. We have built some, we call them profiling units, that have additional sensing equipment that give you more data that we can then extrapolate for future runs of the same SKU. Like we had said, the custom profiles, off-peak, you can interlock with other systems. Really the only thing that is prohibitive in the profile is your imagination with those profiles. And then auto sense termination is the thing that is kind of our white whale at this point that we're chasing. And we have some promising data, but nothing that we're ready to put out into the wild. But right now, if you want to turn off the QFM automatically, you plug in one of these probes into the unit and into your product, and then you can tell it to shut off at 0 degrees and it'll shut off.
The other automatic termination really is once the SKU has been profiled, that dwell time can be stored in the warehouse management system, and the warehouse management system can then send the QFM a termination signal. So that's available today, but we really are hoping that the QFM can do the auto termination with all exclusively onboard items.
And then it's what, I don't know, do we have any of the charts on here?
No.
Okay, so yeah, we've been playing with it says on there dynamic IR array, which sounds way more futuristic, but it's a dynamic IR array, and we're having fun with that. But when we have something solid to share with you, we'll be sure to publish that. I'd like to open it up now for questions. Anne-Marie, was there any questions that came in during our presentation?
Yes, there's a few questions. The first one is, what do you mean by exacerbated? EXACERBATED.
Sure. So we were talking about with our with our older system, with the QF Plus, it was a shared plenum. And when you would pull, say there was a zone of 24 pallets in one zone, and you pull one of those pallets out of place, then the air, instead of going exclusively through the spacers of those 24 pallets, there's a significant amount of air that was going through that empty pallet position, and it reduced the performance of those other 23 pallets. So we knew that increasing the CFM, or the airflow, the amount of air that we were moving through each pallet, was going to increase the performance, but it became a bigger penalty on that shared plenum system. So that's what we meant by exacerbated. It really amplified that empty, the vacant pallet position problem.
And then the next one is, when using a drive, in what is the maximum pressure drop that can handle?
I don't know.
It's in our 8/10.
Yeah, 1 inch is no problem.
Right, it really depends on the pallet that you put in front of it is providing the resistance to airflow. And when our system is at, full fan speed, then, for example, a pallet that has 12 spacers in it, about the most airside drop you can get on that pallet is probably between 3 and 4/10 of an inch water, where a pallet that has fewer spacers, it can go up to an inch of water.
Okay, the third one is, why the difference on SST temp, I think it's temperature, for the QuickFreeze and blast cell? Are they performing the same?
Well, what typically happens is, over the decades, conventional blast cells have had to compensate for the inability to get air through the middle of pallets. They've compensated with lower and lower air temperatures. So what we've been able to do over the past 12 years or so is we tell people we can do the same turn time as your conventional blast cell, and we can do it at about 20 degrees warmer air temperature. So the refrigeration system can operate at a much higher saturated suction temperature, that's what that SST was, and still provide the same turn time. That's a very good question.
Okay, I think we have two more. Have you evaluated the cost per M2 versus cubic evaporators? I see they need more space versus other options.
Did you follow that?
No, you're saying how much cube does the system take up versus like a blast cell? So one way to look at it is, if you compare it to regular warehouse racking, you're losing one pallet position because we're replacing that with the QFM unit, okay? But the performance is so much faster than any kind of density that you could get in a blast cell. So like a 96 pallet position blast cell would be similar to a 40, 45 position QFM system.
Well,
so the density, the pallet density is the same or better, but you also get that single deep select where you can pull each pallet when it's ready, whereas like on a blast cell, you have to wait for the last pallet to finish before you can shut off the blast cell, open up the doors, and start to remove pallets.
Right, and the other advantage we have is, and Bob mentioned this, because we can go so many freezing positions high, most conventional blast cells have that dedicated evaporator up above the racking array, and there's few drive-in blast cells more than 4 high. So a conventional blast cell typically requires more square feet per pallet than we do. But good explanation, Bob.
And there's one more. Can the QFM blast freezing design be a good fit with package ammonia refrigeration systems?
Yeah, I think that package systems, and whether it's, I don't really care what the refrigerant is. We've seen this on a mass scale of, and we've seen it in the past as well, but this move towards these modular package systems is a perfect complement to the QFM, where you can install these, the on-site install times of these package systems is days, not months. And it's the same with the QFM. They really go hand in hand together, and just making sure that you get enough capacity out of those refrigeration systems is the only thing that you run into. We're so good at removing the heat from these pallets that we definitely consume quite a bit of refrigeration capacity.
I think they are very complementary technologies, because you're able to add freezing capacity into a freezer with QFM or QF Plus, and you can also add rooftop refrigeration capacity much easier than some central systems can be added onto. So I think there's definitely some complementary opportunities out there for those technologies.
And I think that's the only few questions that I've seen. Again, we thank you for your time, Bob and Dan. And if you have any other questions, please feel free to send them to me at apenaranda, PENARANDA @fpsa.org. And I'll be more than happy to send it to Dan and Bob. Thank you so much for joining us today for this wonderful webinar, and a very interesting webinar.
Thanks.
Thank you, Anne-Marie.
Yeah, thanks to all of you attending.